You are welcome to today's class, Relative Atomic Mass. Now, first thing, what do we use relative atomic mass for? In isotope, we said when elements occur in two or more form, when elements occur in two or more form, having the same atomic number but different in mass number. You can see this one here is the atomic number. Why this one here is the mass number. When elements occur in two or more form, having the same atomic number but different in mass number, we call it what? Isotope. Okay. Now we use relative atomic mass to calculate the average of the masses. That is, we need just a single mass to represent both of them. That is, we take the average of the two masses. That's what we use relative atomic mass for. And relative atomic mass has a formula as relative atomic mass. This simply means relative atomic mass. Relative atomic mass has the formula to be m1 alpha 1 plus m2 alpha 2. Now, m1 simply means mass of the isotopic one. m2 means mass of the isotope what? 2. While alpha 1 simply means the abundance of isotope 1. And alpha 2 simply means the abundance of isotope 2. I repeat it again. M1 means mass of isotope 1, which is this. M2 means mass of isotope 2. Alpha 1 means abundance of isotope 1, which is this. While alpha 2 means abundance of isotope 2. How will you know the right abundance for this? This was the first isotope followed by this, right? So this is the first abundance followed by this. This first abundance will go for this first isotope, and this second abundance will go for this second isotope. Okay, so what if it occur in three or more form? Our formula, we need to increase what? We need to add m3 alpha 3 to the formula, and so on. So since we are, let's write out our parameters. We have m1 equals to what? What is that? The m1, as I've said, means mass of isotope 1. Mass of isotope 1, which is what? 18. M2 equals to what? Mass of isotope 2, which is what? 16. As I've said earlier, that the one here simply means the atomic number, while the one at the top here simply means the mass number. So alpha 1, the abundance of isotope 1. This is the first abundance, so it's for isotope 1, which is what? 10%. And you know that 10% simply means what? Simply means 10 over what? Over 100. Why alpha 2, the second alpha, is the abundance of isotope 2, which is this. And that is equals to what? 90%. Of course, you know that 90% is equals to what? 90 over what? Over 100. Now, let's substitute these parameters into this equation. We have relative atomic mass equals to what? M1 is what? 18 times alpha 1. What is alpha 1? Alpha 1 is given to be what? Is equals to 10 over 100. It was initially 10%, which is the same thing as 10 over 100. Over 100. Plus M2 is what? M2 is equals to 16 times the alpha 2, which is what? 90 over 100. That is 90%. Times 90 over 100. Okay, so relative atomic mass equals to 18 times 10 will give us what? 180 all over 100 plus 16 times 90. 16 times 90 give us 1440 all over what? All over 100. So our relative atomic mass equals to 180 divided by 100 give us what? That gives us 1.8 1.80 plus 1440 divided by 100 give us what? 14.40. 14.4 is still the same thing as 14.40 here. So if I should add this and this together, it give me what? It give me 16.2. So therefore our relative atomic mass is equals to what? 16.2. So I will give you one for you to solve. Drop your answer in the comments. Okay, now you solve this. Drop your answer in the comments. Option A says 20.5. Option B says 22.5. Option C says 21.0. Option D says 22.0. Now drop your answer in the comments. Solve it. Drop your answer in the comments. See you in my next video.